Hello, my fellow YouTubers. This is Roy back again. Let's go ahead and do a little test here on these coils. We're going to test to see if we can inductively put magnets into the core of the two outside coils. With no connection to the outside coils. Nothing other than inductive. So let's see if you can see this. There's no magnetic field here. There's no magnetic field there. There's no magnetic field going on in the center. So we're going to go ahead and put 1 volt into the center coil. So we're going to, hey guys, how you doing? Who's out there? I get a shout out. We're going to do a little inductive test right now. We're going to put a field into this center coil, and we're going to check with a compass to see if we get magnets into. What's up, Ricochet? What's going on, buds? We're going to see inductively if I'm in my setup here with all these coils. We're building sort of like a software for Ed's wheel, okay? Not to get into the details. The whole basis of this coil system is that this center one's an exciter. And it's also is where you put your load once you get the coils excited. They'll be self-excited after you get the process going. So on this first one, we're going to do a little test here to see if my theory is correct. And what will happen if it's right is that we'll put a charge into this center coil, and we should see north or south show up on the end bar here and the end bar here. And that'll tell us that we're properly lined up inductively to do something. So I was just showing that there's no magnetic field. No magnetic field. So let's go ahead and connect the center coil. We're putting 1 volt into the center coil. And here we go. All right, so we're going to check the polarity on this coil now. So right now we are south on that side, north on that. And that is 1 volt, 0.22 amps, okay? 1 volt. So we said that's our south. So what I'm thinking here is that south inductively going into this core here, which this core has nothing, okay? Has nothing. This core here should turn into, even though this is south, this should be south as well. And on this side here, this side should be north, and this side should be south. This side should be north, this side should be south. This side should be north, this side should be south, right here. Let's go ahead and check this though. So here we are. We got a loaded coil in the middle. So we just checked this. This is south and this is north. Let's see, right now we got a good clearance. We're not touching. And we got 1 volt. And we got 0.24. Okay, and now we're going to check this side. Look, we got north showing up here. How you guys like that? On this side, we got the south showing up. Now remember, there's nothing hooked up to these two sides, but we just filled the core up with magnets. Now what happens when you fill the core up with magnets? So if we were to rotate this all of a sudden, now what are we going to get? Not touching, okay? You got some clearance. Oh, I just pushed it away. This is a good test though. So we're not touching. Now this side, it's going to turn into the south. This side, turn to the north. And let's go ahead and get past the volt now. Let's turn this up. Oh, they were touching. That's not good. That's why I was going slow. So you can see that that's north and that's south. Now let's go ahead and flip this. This is the way I want it set up. And now we are at north here and south there, because what I want here, I want this pole to be the south and this pole to be the north. So if that's the south, that pole's the south. So we got to flip this. So we're going to flip this. And this is how I charge the V-shaped magnet. So I know the induction with the electromagnet. So this side here is north. So that means this end here would be south. This side's north. This side's south. So you're going to see now, there is no, you're showing south there, nothing really. Magnetized, it's done. So there's no magnets going on here. I still have the field going here. So you'll see that this inductive, pretty damn cool, because we just turned these coils. So these got magnets in them, okay? So there goes the start of the array of all these coils. They are going to be set up in a certain way. This center coil strip is going to be where I put, it's going to be called the inducer. It's the inductive start of my Ed Lee Scallon's inductive self-exciting magnetic wheel. So Ed was making lots of power, but he wasn't doing it per se with the magnets he has here. He was doing it with some coils that he had up on the wall. You can see it was a bunch of coils. So pretty good test. I hope you guys leave your comments. Right now we're only pushing 1 volt. Let's turn it up. Let's see what we got here. Something. Let's see, why are we only, I think I got my, ooh, whoa. All right, let's see. Watch this, guys. So, let's get, I'm going to turn this up until it pulls, something happens. All right. Strong magnetic field. Pull together. You can see the gap on there was pretty strong. And let's pull it apart even further. And the object now is not to let it pull together. And we're going to check the compass. Let's put the compass right here. So right here on the compass, it's showing north, because we do have this center still on right now. But right now we are shooting 1 volt, 0.23 amps. Now I'm going to go ahead and turn it up. Right now we are at 15 volts. Let's go up to 24 volts, and this is 5.75 amps. So we got a good magnetic field going. So that coming out of that coil is south, going into this coil is north, coming out of here is north. So going in, no, that's actually, I was wrong. Coming out north, stream's running right through here. I think I just changed the polarity on my compass here. So that's pretty strong inductive powers there, electromagnetic. Okay, electromagnetic. All right, guys, stay tuned. I'm gonna start putting this thing together, start building it, and we'll put the pieces together. You guys can see how this is gonna work. Take care, man.